all days. So again, well done to finish the program. Just before we start, anybody is familiar with Wikibase? Have you ever heard of it?
Preparation materials called it.
Do you know what is Wikidata? Okay. Do you know what is Wikipedia, right? So Wikipedia used to be the first project of this kind of collection of projects. So it was created, just a bit of context. So again, it's an online encyclopedia that everybody can edit, right? So as soon as it started to grow in terms of size and complexity, they immediately realized that it was pretty effective for human beings to read through the information, but the information was not presented in a structured way. So they started at one point to have the info boxes, but was still not good enough. So at one point, somebody in Germany, I think, decided within the Media Wiki Foundation started discussing about having actually a software to deal with the structured part of the data created by Wikipedia. Okay? And that will be, again, the Wikidata project. And Wikibase, which is a website, Wikidata is a website that you can go. And it's basically a sister project of Wikipedia where you have structured entities that are extracted from the main articles that are connected through relationship. Okay? So Wikibase is the software that is powering Wikidata. In fact, it's an add-on to the main software of Wikipedia, which is Media Wiki, Wikimedia. Well, one is the foundation, the other one is the software. Never remember which is one. So the main software powers Wikipedia, so Wikibase is an add-on to that software. Okay. So when we use Wikibase, in fact, you're using the software powering Wikipedia plus this add-on to allow you to do to enter data in a structured way, which is kind of the reason why we decided to use it. Okay, so there is a kind of a part where we talk about interdisciplinarity, mixed methods early on, how to design this kind of project that are embracing different types of data, but also different kinds of with questions that are coming from different disciplines. And then we will have a second part where I will go through, it's kind of a demo. You can follow up if you want how to use the software itself, okay, which is provided by a website, but can also is open source, so you can install on your own machine. For convenience, we will just go through the implementation offered by by the German Wikimedia. Okay, so the idea of using Wikibase is to take the research project that collects a diversity of data, different types, messy, with very complicated relationship among the different data items, and put them all together in a single place, a website that you can consult and navigate online from using a browser, creating what we can refer to as a knowledge graph. Okay, so the knowledge graph is different from the traditional knowledge. The knowledge base is everything where you put documents, right? The graph is stressing the relationship among the different items. Okay, so you're not just entering information, for example, Wikipedia articles, right, or whatever, numbers or images, but you're relating the entities within your knowledge database. Okay, so for example, you're relating an entity that can be the author of a social media post with the actual text of the social media post, with the image, or with anything else. Okay, you explicitly define this relationship, and of course, at the end, you will construct a graph that you can navigate, and importantly, that a machine can navigate, right? Because this graph is not just for people. This graph is for both people and machines, and this is one of the most interesting aspects of the software Wikibase, and in general of knowledge graphs. Okay, all right, this is me. Not that interesting. I'm also deputy director of the Center for AI Trust and Governance, which paid the trip to Melbourne. So I think we should mention it. And so yeah, as Katerina mentioned, what we're going to talk about is part of this book that was published a couple of weeks ago, but is actually the product of the use of Wikibase that we have done through a number of years, okay, on different projects, mostly using social media data, but you can apply, I think, to different kind of domains, okay? Again, this is my email if you want to contact me, and if you can access these slides, also there. That will be a few years ago. So this is the book. It's actually not just by me. So as I mentioned, we need to mention the co-authors. So Emily Booth and Jennifer Williams. They were both on different projects with me. So Emily is at UTS. Jennifer Williams is at McWhorter. And to be also, I think, important, no one is a computer. So we had also computer scientists on the team. They co-author some of the chapters, but Emily and Jennifer are not computer scientists. Actually, they're social scientists. The first metaphor that I used to explain what Wikibase could actually be for a research project, an interdisciplinary research project, is a table, right? Mm-hmm. So the idea is that you have you set up a research project. So you bring people together around some sort of research question that require the analysis of different types of data, right? But again, these people are coming from different disciplines. So they will have a different set of concepts, different set of vocabularies, different set of methods to use, approaches to use it, okay? So, this can be seen as inconsistent. So the idea will be to set up Wikibase not later for the analysis, but from day one, okay? So you set it up and you start collecting Wikipedia data in Wikibase since, again, the first day, right? This is possible because Wikibase is flexible enough that allow you to put the data in first and then structure it later. Okay, of course, it's a wiki, so you can change it as much as you want. And the idea will be that you can keep changing it as much as you want throughout the entire lifeline of the project. And when the project is completed, again, you can actually publish it if you want, and everybody will be able to access it. It's quite intuitive. And by the way, it's also the kind of tool that does not require any training. It's a website, okay? It's built on Wikipedia software, so it's pretty intuitive to navigate as a user and navigate and access as an editor, right? So again, this is the kind of story that if you've been part of this kind of interdisciplinary project, you might be familiar with. You have quite a chaotic data management situation. We have different types of data. Everybody has a different way to approach them. And mostly, again, the data start just accumulating without any implicit structure, right? And if you don't have a structure, then you cannot read your data, but also a machine cannot query your data, right? So, and then maybe also it's not just that, the lack of structure, but the data is distributed across systems, computers, formats. I mean, you might be, I'm sure you're familiar with this kind of situations, right? So Wikipedia and plus Wikibase respond to this kind of problem. They create one single table, which with one single URL address everybody can reach, where everything is located, right? So you don't have things distributed across. You have everything in a single place, and all the documentation, all the notes produced through the project, the data, and also the activity that you want to do, the task that you want to complete on that data are all in a single place, and which again bridge the discipline gaps because it's easy to access. You don't need to be a computer scientist to access it. Computer scientists can leverage on the most sophisticated features of the software. So like, for example, the API or the SPARQL query engine, which we'll see at the end of the class. But if you don't know what they are, you can simply search it and navigate it by clicking and following the links. So what is interdisciplinary research, right? This is the concept of the interdisciplinarity is behind the justification that we're using for using Wikibase on other kind of tool. So this interdisciplinarity is about creating together a shared definition of what is the research problem, and then trying together defining of developing the methods to solve it, right? So multidisciplinarity or other forms of multidisciplinarity are, of course, mostly happening in parallel. So you bring computer science, they will do their own thing. You bring the social scientists, they will do their own thing. Psychologists, economists, they will do their own thing. And then you bring the results back together on the table. And then you try to discuss how these results can integrate together in a convincing story, right? The interdisciplinarity approach is instead different, right? You do the results together. You produce the results together. And of course, this is more challenging because you will need to get out of the different silos and possibly also develop common understanding and a common vocabulary to do this. Okay, so not parallel mini projects, which is probably what we can call multidisciplinarity, but instead a coherent, integrated from day one interdisciplinary project. Okay? This is difficult to do because if you've been long enough in a single discipline, leaving that discipline, which of course interdisciplinary requires, is uncomfortable, right? Because it's just like speaking a different language, right? You are comfortable within your linguistic community. You understand everybody else understands you, right? You don't need to put a lot of effort in defining and every single step of the process. You just present the package and they will buy it because they are part of the same discipline. Okay? Interdisciplinarity is about stepping out of this comfort zone, right? And because this is uncomfortable and difficult, you requires all the possible tools to do this and to make this as feasible as possible, right? Because again, and one way to do it is again through transparency and through documentation. That is a constant process, right? So you don't drop disciplinary definitions. Instead, you can constantly redefine them together across the different steps of the process. Again, yeah, any question at any point? Is that a question or no? All right, so any question at any point, please feel free to stop me. Research tells when disciplines speak incompatible languages, of course. That will be going back to doing something different. You do it in parallel, and then you try to bring together the results in some form at the end, okay? But you're not deploying and developing an interdisciplinary project, right? You're doing something different. The key word when it comes to interdisciplinarity, and in some sense also a mixed method, is the integration part. Right? Multidisciplinarity, you work in different rooms. So think about economists in one room, sociologists in another room, computer scientists in a different room, and they work out their problems, their solutions, their data, their approaches, their methodology, and they bring it together at the end, just before the publication starts, the write-up starts. Okay. Interdisciplinarity, again, is working around the same table from day zero. And this table, the metaphor is Wikibase. So you integrate everything, right? Assumptions, methodology, which is very challenging, and the design and the definition of a different part of the research problem that you have. Okay? So Wikibase is our metaphor, a mechanism for this kind of shared table around which your interdisciplinary team can congregate. Okay, so why is this kind of table works well as this kind of table? Again, because it's a workspace. It's a digital workspace, right? It's actually a software designed to provide affordances for these exact problems. Because allowed collaborate simultaneously from different points, right? Not in sequence. So you don't need to ship the product with an email so that the other part of the team can do something. Everybody works on that at the same time. Of course, the software is powering Wikipedia. You have thousands of contemporary editors all the time. So it's pretty robust in that sense, right? Try to do something like that on a Word document on SharePoint. Good luck with that. It breaks down the silos between qualitative and quantitative. This is another important aspect. We will discuss what we mean by the difference between quality and quantity, but you break it down. You don't need to have a formal distinction between what kind of data is qualitative and what kind of data is quality in quantity. In fact, you don't need to worry about that until you start approaching and doing some. You don't need to worry about that when you do the data collection. You can worry about that later together. Okay? And you have a single story to share with the entire group, right? Because you can, of course, accumulate the documentation, all the documentation there. So again, a few examples of what we mean by interdisciplinary versus multidisciplinary team. The climate change silo is a good example of this. Again, you can think about working on climate change, right? You can have economists developing their own models, and then political scientists apply these models, but they're not working together the same kind of research problem, right? Instead, interdisciplinarity is exactly this, integrating so that every single team contributes from day one, from day zero to the design of the project. Okay. So again, political stability indicators. So the political scientists might modify climate models that are developed by climatologists, right? Or climate tipping points can inform the modeling of the economist, right? You don't have an economist shipping the results from an econometric model to the climatologist. Instead, you have the climatology discussing with the economist, econometric person, how to bring everything together. Okay. This is our example, okay, closest to what we actually did. So we look at social media data. We were interested on a number of research problems that can be answered using social media data. Social media data communication technology are a good example of this kind of research problems that really benefit from an interdisciplinary approach, right? You have social scientists that are being trained mostly using qualitative methods. You have computer scientists that are mostly used on and trained on, well, let's say exclusively trained on computational by definition problem. But then you develop together a shared framework to accommodate what we were studying, the research problem, for us, hate speech observation using structured and unstructured data. Okay, so we had manual coding, qualitative coding done by social scientists would inform training algorithm, classifiers, etc., and then looping him back into the human side of the training process, so that we can benefit. Each side could benefit from it, but each one side also could understand the shape of the data and understand how to contribute creatively also to answering and addressing the research problem. Okay, so interdisciplinarity requires a workspace, and this is essential because it's not just about defining it in an abstract sense. It's also about finding how you do this in practice, right? Disciplinarity requires a workspace that is accessible to all and it is comfortable to everyone. Because if you give the features of Wikibase to a computer scientist, that person is going to be comfortable in understanding the architecture, right? If you give it to somebody, social scientist, qualitative researcher that is not familiar with anything computational, they will also be familiar with that thing. Okay? So it's not creating barriers, but instead it's creating a space where they can meet together. Maybe they can also exchange notes, right? You have an example of the kind of problems that might arise. So if you've been working with spatial data, you might have encountered data sets such as this one here, or such as this one here. You don't even know where to start if you're a social scientist. You might be interested, again, in the geography aspect of this. This data might inform some of your research, but you don't know even how to access it, what kind of software you need to use, etc. So this kind of formatting, this kind of siloing that research is clearly creating a barrier. The person that is producing the data is not making the data accessible to the person that would like to use the data potentially, but does not know how to even access the data. What is the software to read it, right? Wikibase provides instead a web-based interface, which is kind of universal. If you can browse the internet, of course, you can use it, and lowers the barriers, okay? Is, of course, a methodological choice. Because if the conversation is a kind of interdisciplinary research is the constant deliberation, well, you need to have this barriers very low. If you have barriers, of course, you're not doing interdisciplinarity. You're not applying interdisciplinarity anymore. You're doing something different. Maybe you're doing multidisciplinary instead. Okay? So, Wikibase allows, we think, to develop a common language. Okay, and to capture this common language in a single place, that is a website that is accessible to everyone. Okay, so who can use Wikibase? Is Wikibase right for your problem, for your research problem, your research team? We kind of flesh out 3 questions. If you answer this question in the affirmative, then probably Wikibase is something you might want to consider. Okay, of course, it's not for everyone, right? But if you have a team that is sufficiently extended in terms of and diverse in terms of disciplines involved and data involved, then probably that is something you might want to consider. Okay, so can you address the problem using a single data type? If the answer is no, no, sorry. Yes to the first. Well, anyway, you got the point. If you need to answer this question, not only the affirmative. So if the problem can only be addressed by one data type, then probably Wikibase is not really for you. There are software suites that are more appropriate for one single data type. Can you practically and ethically collect only one data type? Right? Of course, if the answer is no or yes, depends on what kind of data you're going to use. Sometimes it's not ethically possible to collect more than one type of data. And does the team has the capability to handle multiple data types? Okay. If yes to the first, mixed method might not be necessary overhead. Answer 3 before connecting. All right. Final ethical consideration. You discuss a bit ethical consideration and the ethics of doing this, right? Of course, they're always there, right? So there's something you always want to consider. And in some sense, by making your research more transparent to the entire team, but potentially also to the people outside of it, you are addressing in the right way ethical consideration that always arise when you use data generated about, and when you use data that is about people. Okay. So other research benefits, for example, can justify higher participant risk. Okay. So that's the point of this. The ethics of doing research using diverse type of data is never like clear cut. You might accept more risk for participants if you hope to get more benefits out of the project. Okay. But also you don't want to collect data no matter the risk, because there is always some sort of risk if you don't have a clear idea on how this data is going to be used. Right? So this is again why transparency in the data collection process and the why Wikibase can help on this. Right? Anybody has heard about data surfacing or surfacing? No? Anybody heard about? Sorry? Palantir?
I'm interested in data, so I just kind of like whenever it's related.
Yes. Do you know about Palantir?
Palantir, yeah.
Yes. Okay. So Palantir made like the point of data surfacing or surfacing quite core of their business, right? So what they do is they collect the data. Well, in fact, they don't collect the data. They have providers giving them the data and then asking the question later, right? So you collect the data, so the point is to get as much data as you can without really understanding how you're going to use it. Okay. Then you take all this data, you put it into some sort of algorithm, and then the patterns, eventually some patterns will surface, right? This can be a good business if you want to can be a good idea if you want to turn your business in a multi-million-dollar enterprise, but it's not a good research practice. All right. The good research practice, and in fact, no ethical committee, at least in Australia, will ever approve something like this. You cannot go to the ethics committee of the university and say, just give me access to all the data I can get my hands on, and don't worry about what I'm going to use it for, right? No. You need to say exactly what you're going to use it for, how you're going to use it, what is the methods, and whether it justify the ethics and the risk that you put your participants into.
Would the term apply to regular exploratory? So, for example, I want to do some research on how news reports everything in relation to a specific event, for example, right? So, how, for example, news report on One Nation's speeches, right? So I just collect everything.
Yeah.
And then would that be classified as data surfacing? Because it's still kind of explorative stage, right, of analysis. Sometimes you need to do it, right, before you kind of approach your research question.
Well, I guess it's really about balancing the risk. If you just like news data,
social media data, for example, I go to Telegram accounts and I collect discussions.
Yes, but that's a different problem, because then you're splitting. So you're creating a data collection apparatus that then will require an ethics later on. Okay, that's a difference. So you're not collecting the data and then giving everyone access to this data. Okay, so for example, the QT Internet Twitter archive works in this kind of way. So you collect the data because you know that this data is not going to be there in 5 years, in 5 minutes. But then before somebody can access it, then they will need to put the ethics in. Okay, about that specific approach that they want to use. Okay, so that's in some sense rebalance rebalance the problem. Data surfacing is just about trying everything, getting any kind of possible patterns, and then selling the part that they're
See what sticks.
exactly right. So they're using it, for example, for ICE kind of operations. Say, give me a list of potential illegals, right? It's good research. Then whether we're predicting whether they're going to actually be research or not doesn't really matter. Okay, but of course, if the ICE wants a hit list, you're going to provide that. But is doing research, understanding patterns is a very different kind of problem. Yeah. Okay. All right. So this is kind of messy introduction just to kind of justify why I think it's a cool thing to use Wikibase. Okay. Again, we went through the details already. Why is not just a cool thing to do use Wikibase, but why is a cool thing to use Wikibase if you're interested in doing something interdisciplinary? Okay. Not everything should be interdisciplinary. Disciplines are important, of course, in academia. They play a function because you need sometimes a silo where to develop specific ideas, specific concept, but some problems don't fit there, right? So you need something to create research, to create knowledge outside of the silos. And Wikibase can play that role if you want to develop and carry out an interdisciplinary project. So what is Wikibase? So it's not a standalone software, okay, but an extension of MediaWiki. So MediaWiki is the software behind Wikipedia. Wikimedia is the foundation. So it's complicated, but that's the right thing because in the slide. So again, MediaWiki provides a website and the wiki functionality that the project lies on. Okay? You go on a Wikipedia article that's powered by the wiki, by MediaWiki. You know that mostly you can edit it. If it's protected, of course you can't, but you can edit it. So again, you can either navigate that as a regular static page, or you can open up the editor and you can change the content of the page. Okay? So you get that. But then on top of this, you get another layer which allow everything you put in to be structured. So you put in special items, data items. Each data item will have its own URL, unique URL, and then you can also define the properties connecting these data items. Okay? So you provide this structure layer to any kind of content you want to put in. It's very good because it's open source, so that means it's free, and is actively maintained by Wikimedia Deutschland, which of course, why they maintain it, because of course it powers Wikidata, right? So it's not a kind of project that somebody created and that will forget about it. So we can count on we can count on this project being actively maintained over the years. So again, the MediaWiki is where you have the collaborative web pages like wiki text, images, and videos. Wikibase is part of a set of special pages, like the integration of the add-on, that allow you to define items with the letter Q and properties starting with the letter P and then some number after that. Okay, so together they both handle, and these already giving you some flexibility because they both handle the unstructured part. So think about it, just a text or video, whatever file you can put on a website, and the structured aspect of it, the information, because you can connect items wherever you want. Okay. So you never have to choose between either a wiki or a database because you can get both, right? In the same website. So Wikidata, I discussed this very briefly before, is again the world's largest Wikibase instance. Okay? You can access it by just clicking data.org. Looks like this. Okay. So, and then you click one item and it looks like this. Okay, so this is the item Earth, right? As you see here, the label is not there because, of course, it's multilingual also. You can change the labels here without affecting the schema. So this item is identified as a Q2, right? And then properties are instead the one that are defining the relationship between items. So, for example, the property instance of is here, and you see there is identified by P31, okay? Then can you guess what is the item 42 in Wikipedia, in Wikidata?
42. The number 42.
Yeah.
Life?
Now, being a bunch of nerd, what
Oh,
can
no, it's a question to the meaning of life, universe and everything.
Douglas Adams?
Yes.
All right.
Oh, thank you.
All right.
Pretty much.
You were close, yes. Okay. Again, the label is not in the identification. The identification is Q42, and then you link this Douglas Adams is a person with, and actually you can see here different labels in different languages, two other entities. For example, instance of human, right? Signature, so here you have an image, right? Or sex or gender, and then male is going to be another entity, while sex or gender is a relationship connecting the two, okay? So this is, of course, as you can imagine, highly contested, because how many can we have on the other side, right? But you don't need to choose, because you can have multiple definitions. In fact, you can also have contradictory definitions of it. Can be male and can also be female, right? It is not breaking the schema per se. It's not breaking the ontology that you define. Okay. All right. All right. So the aim of Wikidata is again to make the knowledge created by Wikipedia machine readable and discoverable, but also relational in some sense, so that not just machine can read it, but also people can read it and querying it using machines. So the data model is pretty simple, right? It's very, very simple. That allow, again, everyone to understand and to grasp what we're talking about. So you basically have two specific things within it. So you have items, which again are things. I do define what they are, okay? And so they're defined by Q plus a number, and then the properties, right? So that are linking items together, P plus a numbers, right? These identifiers are persistent and are just numbers. So you keep them there, but then you can change the labels as many times as you want. And in fact, as we've seen, you can have multiple labels, right? So it gives you a sense already that you're doing two things. We'll discuss it in a bit. You are creating an ontology, your labels, and a schema, your structure, right? You can change the ontology as much as you want without compromising the schema, which is just like pointing one number to another number through some number property, okay? So stable idea again means that rename constant never breaks the link at pointing at it. It's very different from having a URL with a specific name domain, which of course you change, because if you change it, you break it. You don't break it here. Okay. And the idea to understand, behind understanding how it works in a very essence, is the idea of the triple statement, which is not invented by Wikibase, by the way, but goes back to again, the idea of a graph, knowledge graphs, okay? So you have one item here, another item here, and then you connect them through some sort of property. And this is the triple, right? Subject, property, object, okay? It goes one way. And this gives you the basic structure of the schema that you can create. And then, of course, you start adding, and then you have a graph, right? Because this can be connected to other, and you can navigate this graph. And the way we do it, we can do it manually, clicking on the links, or we can use a query language. It's called SPARQL to do this. And we will see this, okay? So the way we do that, of course, each item will have a number of connections, not just one. This is the idea of having a graph, right? And then we group them in statements, right? So we group these statements, so the triple, in different groups, right? So for example, you can think here that is also visually clear when you navigate the site here. You have a number of groups. So because again, given name, actually you have two, right? That's mostly the case. So what is the name of Hillary Clinton? So you have a number of possible ways to actually formulate that. Given names, you actually have two, Douglas and Noel. Family name, just one, okay? But then you see here that you have a group of statements all together because they share the same property. Okay? And then, of course, sometimes you don't want to link the item to another item, but instead you want to qualify it maybe with a number or with a string or with a file, for example, an image, right? And you can do that, all right? So you still have your property here, but instead of linking to another item, you specify what is on the other side of this property, and you have a number of data types that you can use, right? Again, for example, it can be a string, or it can be another item, or it can be a number. Essential data types that you can use, and this list is growing, are again string, quantity, time, URL, so that you can link, for example, your data knowledge base and knowledge graph with somebody else's knowledge graph. Okay, you can link it by sharing IDs throughout. You can have time. And again, external identifiers. So for example, if you have a researcher, you can have the ORCID identifier, or you can have, if you're studying parliamentary speeches and you're referring to some database that provides all the text about this, you can, of course, the MP there will have some sort of identifier, and you can link your data with somebody else's data, and then you can actually be able at one point to do federated queries. So instead of querying just your knowledge base, you're actually querying both at the same time. Okay. Any questions so far? All right. So that was a very quick introduction about what is the essential vocabulary to understand how Wikibase work. But again, it's pretty simple and pretty straightforward. Okay. Now let's talk about instead the project design. Because Wikibase, the technical part of it is pretty simple. Has to be simple because it's to be usable by many million people without any technical expertise. But the point for us is to use this for research purposes. Okay, so you need to place some sort of design thinking on top of it. And you need to start thinking also in terms of ontology. Okay, anybody is familiar with the word ontology? This specific context? Okay, so there are many different ways to approach ontology, okay, epistemology ontology, but this is a slightly different way to actually approach it, right? So I think the best way to put it here, I mean, this is not written in stone. This is how we can think about these three words here. Does not need to apply across. But the way to think about this is again as three different layers, right? So you have the code book, which is the traditional way that is used by social scientists to add labels to what they're doing, to their data. Okay? So the primary user here is a person. So think about, you go through your newspaper article, as example before, and you start highlighting aspects or mentioning the article, and you add labels to that. Here is a person, here is a theme, whatever. Okay? So this is your code book, right? Primary user is a person. Core functioning encodes some meaning. Of course, these labels make only sense if you attach a human kind of meaning to it, right? And then this is highly flexible and unstructured because there is no limit on how you can use it. Okay? The data schema is instead kind of blind to the different labels that you use. And in fact, you can replace the labels without breaking anything. And is used by a machine to navigate your graph. Okay? It encodes relations, not meaning. Right? So this is what we call a schema. The ontology in this sense is when you combine both, right? So you define expressly what is a property. So a property as written cannot link an animal with some sort of place, because of course animals cannot write, can only link, of course, a person to some book, for example, right? As written. From a schema perspective, you can link an animal to a book, right, as written, but then, of course, from a human perspective, the code book will be totally meaningless, right? So when you mix the two, you think about it in terms of an ontology. The ontology encapsulates both the relationship among your entities and provides a meaningful label to these entities and relationships. Okay, so you can interpret that in a meaningful way as a human being, but also you can leave a machine to navigate that. Right? So you can you can extract human meaning from a graph using a machine to navigate the graph. This is basically what we talk about when we talk about ontology here. Okay? Which is again what I just explained here. So, and this is an interesting aspect and why it makes sense in the context of Wikibase, because codebooks require data. Ontology, as they are conceptualized here, they don't. So you can start with a basic ontology even before you have collect any kind of data, and then you use that to inform the first phase of data collection process. And then, of course, the ontology will evolve as you go through it. So you can define a worldview before the first interview, okay? And also you can involve non-technical people to try to understand how this ontology is going to look like, right? And this is the ontology discussion, also in a personal experience with our interdisciplinary research, was the key moment where the team came together. Computer scientists and non-computer scientists, social scientists and security study people, because you start defining what really matters in relation to the problem that you want to tackle. Okay, so what is a theme, for example, when you're studying security issues on social media and hate speech in social media? Okay, computer scientists will need to understand the voice and hear the voice of the social scientists, because they will need to apply what they have heard to the computational aspect of the task. Okay, and you define this explicitly in an ontology. So, for example, some item is as some property as theme that links it to another item, and then again the computer science will be able to act upon this because it's been defined there, and the computer science will be able to access the schema part of it, while the entire team understand, including the computer science, understand the labeling part of it. Okay, so this is a very, and then again, this ontology can be captured within Wikibase. So Wikibase can capture the ontologies plus the data that will come within it once you start collecting it. Okay. So you can start again with a dedicated software like Protégé. Anybody has ever used Protégé? Okay, it's another open source software. You can't really do data collection, but if you're just interested in defining the ontology, you can work on it. This is again something you can download. It's also a version online, but technically you don't really need to do it. Okay, you can do the ontology definition and development directly in Wikibase, and we'll see in a second how to do this. Okay, the point here will be to start from a small number of entities that you define and relate with each other, and then you start growing it. And there's a constantly process of redefinition. Okay, so for example, in our experience, we define a essential ontology for early on, then we collected the data from social media, and then we went back to the ontology later on, okay, to try to redefine it, to attune it better to the problem that we wanted to answer. Okay, so it can be also, you don't need a software, you can just sketch it on a whiteboard, for example, there. Okay, so your item and your connections, your properties, and your and the other items. Okay, these are the essential component of your data collection process. Okay, but then you don't stop there. You also start discussing on how you connect them, with the key part that you don't want to have any orphans, so basically items that are not connected in some sense to the rest of the data set. Okay, so the ontology, of course, are a growing beast, right? As the project progresses, you will keep redefining it, and Wikibase, of course, allowed to do this because Wikibase will live and breathe through the entire life cycle of the project. Okay. You can also think about having meetings specifically every few months to make sure that they are in line. Everybody's in line with that. You will need this meeting. You will need this moment where people back to the table, right? If you don't, the interdisciplinary project will disperse. The team will disperse. Okay. Anyway, it's something that lives with you, and you can keep deliberately change over the life of the project. Okay, a few more details on this. You can think about ontologies as codebooks. I just wanted to go quickly to the part where we start working with it. But again, as always the case, you can redefine them forever. At one point, you will need to stop redefining them and say, okay, this is good enough. It's never going to be perfect, but it's going to be good enough for what we can do. Okay. A few example again: item, book, instance of paper object. Okay. As you can see, they're really flexible. It really depends what is the scope of your project. They can be very wide. At some point, they will need to stop though. Okay, with properties like author, publication year, number of chapters. Okay, this maps the word that you want to be locating where you want to locate your project, and you needs to be a word where every data item of your project is comfortable in that sense, can be linked to the rest of the universe that you're going to collect. Okay, another example. Okay. All right. Last step before we start doing the hands-on with the software. So another metaphor here. So we start with the metaphor of the table. The other metaphor that I think is useful is the metaphor of the layering. Okay. So we talk about a distinction between qualitative and quantitative, right? Which is very, very important mostly as a way to identify researcher, right? Especially the social scientists. So are you a qualitative researcher or a quantitative researcher? Because they will speak different languages, right? If you're a social scientist that does quantitative work, you know that it's really hard to sell your stuff to qualitative people, okay? Because this distinction is not just about the methods, of course, it's also about the ontology in the other sense, right? So our idea is just like to stop thinking about that distinction and instead thinking about a continuum where you have unstructured data on a continuum that can lead to structured data, okay? And actually every kind of data set, every kind of data item, so think about an article, can start from being totally unstructured. Think about a news article, for example, right? There is no structure. Well, there is very limited structure. So there is, of course, end and a finish, okay? There is some file formatting, but then you can keep adding structure to it, right? So you can push the very same data item that is not either qualitative or quantitative towards the continuum, towards a more structured form. And this is exactly what you can do, for example, with Wikibase. Okay, so take an article, you start adding labels to it, right? Like think about using XML or JSON, some sort of tagging system. Okay, so you give the article some semi-structure, and then you keep adding structure to it, and you actually start relating everything that is mentioned here to something that is mentioned outside of it, and to other data items, and then you provide them sufficient structure. Okay. So again, this is the idea of the different layers. So the real world is unstructured. It's not quality or quantitative. What is a news article? Is it qualitative or quantitative? Well, it depends, right? Can be quantitative, can be qualitative. It's definitely unstructured to begin with until you start giving it structure, right? And so you start identifying items within your data, and you start relating the data together, and then you start moving from here to a structured knowledge graph. And this is the kind of process you go through when you use Wikibase. You start adding your data, and then you start adding connection that links that specific data item. You break it down, maybe in different parts, and then you link each part to something else, and then you give it structure, right? And again, here the layering metaphor, right? You keep adding layers, and then the analysis does not need to be restricted to any single layer. In fact, the analysis can go up and down here, right? The same thing can be analyzed over the different layers that are composed of. Okay, you're not rejecting one layer when you keep adding structure. You're simply moving up in providing more structure. And then where this is going to be when you go to the analysis phase is up to you. And in fact, you can move around the different aspects. And the integration between the different methods, qualitative methods and quantitative methods, is basically defined by your structure. Okay, so you can do some qualitative analysis here and then quantitative analysis there, computational analysis there. Okay. Again, a few examples: text, audio, images. This is an example of unstructured data that can be stored as pages on Wikibase. Okay, then you can start adding some annotation. You start reading your text. I mean, text is the first most common form of data in social sciences. So you start adding labels. Who is the interviewer? What's the data? What they're talking about. Okay, and then you start relating the text, what is mentioned within the text, with something that is mentioned in another text, and then you start having your graph. Okay, so the kind of layering that can power really your research and allow your research to move freely across the different dimensions of the data. Okay, so the layering is a good metaphor because it's not about transforming the data. Okay, it's about enriching the data. So you can, of course, quantify a text, but I think you still want to maintain the possibility to go back and forth, right? To go back to the original layer, so that again you keep maintaining some sort of flexibility when you do the research at the end. So when you do the analysis at the end. Okay. Any questions so far? All right. So the last half an hour or so, what I propose you to do is to either you can do it yourself or you follow along what I'm going to do. Okay. So what we're going to need here, so we're going to basically now use Wikibase, the software, to do something. We enter some data and do something with that. Okay. So we haven't mentioned about how you actually do this in practice, but there are different ways to install the software. So you can, the most common approach will probably be to have it installed on some server, web server, so that everybody is on the internet. You have a single domain, everybody can access it there, okay? But then, of course, will be when you implement it and deploy it in the real situation. Here, we're just playing around. So you can either install it on your computer as a Docker, okay? But also is provided very easily and freely by the Wikibase development team on this website here. Okay, so if you go to wikibase.cloud, right, you can actually create for free up to 6 instances. There are a few limitations, okay, because they're also providing paid kind of model options. But if you go here, I already logged in, you can create an account for free. And then once you have created the account, you can go to the dashboard and you can create up to 6 wikis. Okay, so I can just show you quickly how to do it. It takes just a few seconds for the email to confirm. So once you have created, you will need to confirm it. And then you can create a new one. So just name it whatever you want. Let's call it Q2042, for example. Okay. And then you can put here whatever you want. Let's say Douglas. Okay. Just make sure to add your user. This will be not the user for this account, for the Wikibase Cloud dashboard, but the user for the actual website, because this is going to be an actual website. And you can call it, for example, admin. This is case sensitive, so be mindful of what you use. Okay. And then just decide to click one of those. So let's say learn about the tool. Then let's say it is temporarily. You can just actually will not use it after a while, and let's just create the wiki. Okay. So the wiki now lives here on this website, which is again quite a familiar kind of interface. It is basically the familiar interface of Wikipedia. Okay, which looks like this. Okay, so I already created it, so I didn't have to go through the confirmation, because then you will receive an email with to reset the password, and you go back to there. So I already have another one, which I used. I just created, so we can go quickly to that. But again, it's a new school of thing, Melbourne 2026. Okay, so I already created just before. I can go there. So then here, again, this is open to everyone, by the way. This is one of the limitations to using this. You cannot really password protect it. If you want password protected, then you need to find a different solution. This is a website, and then you can log in here with your account that you just created. So in my case, was the email address. Okay, and then here will be my password. Okay, and then you log into it. Okay, so now I'm logged in, and this is again the familiar interface of Wikipedia. All right, you just create your website, you create your account, and now you're good to go. All right. So here I put together a few things to do. Well, I'm not sure we will have time to do everything, but just to, I mean, the documentation is still going to be online. So again, create the Wikibase instance with what we just did. So then you define the ontology, you created the property, you import some data. You can, of course, do this manually, but it is easier if you import it instead. And then you do the query of the graph that you created with using SPARQL, which is a language. A query language is similar to SQL, but of course, the SQL is for relational databases, so kind of two-dimensional database. SPARQL is for query a graph, so it's kind of the same philosophy, but of course, the syntax is going to be different. And then we can leave some notes for that specifically there. Okay. So in order to do that, you need to download the data that I put here in this repository. So okay, there is a README here, and the data that I created is there. Okay, so the file that you need to copy, actually, you don't need to download this. You can simply copy this. Is this one here? Okay, so let's just keep this open and just follow this instruction here. Okay, so again, this comes with a number of features that allow you to import data sets. You can do it manually, of course, the data entry, but you can also import it through a number of APIs and a number of tools. And we will see one of these tools later, okay, in a second. Any questions so far? Okay, let me go back to my slides. Where's the slide? All right. So we have created the, again, this is the three options for you to, this is basically the one that you want to really to adopt if you have a team and you want people to access it from the web, okay? So there's a Linux web server somewhere on your university website, and then you install the software, which is, of course, is available for free because it's an open source project. Another option, you can try to install it on your laptop, like in a Docker container, okay? You can actually install it in a Linux server with a Docker container, but yeah, anyway. This is the most accessible one, okay? We do this because, of course, it's pretty easy to do. We don't need to deal with the installation part, which there's always something that is not working properly, okay? Okay, the problem, of course, of using this is that the data is going to be publicly available to everyone, okay? If you want a private one, you can explore. This is still a beta, by the way. Wikibase.cloud is still beta, but there are like a paid options for you if you want to use it still, okay? But for practice, it's perfect, of course. All right, so you need to verify the email. You need to create you choose a name. I just did it. It's okay. We're going to use Melbourne 2026. Okay, and this gives you the wiki itself, which is this one here. Okay, where you create. This is a normal page, and then we will going to create the items and the properties. But gives you also the possibility to access the quick statement tool, which of course allow you to import. So let me just duplicate this to allow to import the data more. If you have a large data set, of course, this is convenient. So you just take this out and you just paste tools quick statement. Okay. This is again the backend, let's say, to your website. Okay. Here we will paste the statement. So we'll import the data from the script that I showed you before. And then the third thing that you can do is to query the data, right? So this will import the data, and then you query the data once you have the data there, which is the final step. So again, I can duplicate this, and then I just replace this part here in the URL, and I just write here. Okay. Okay. So here again, you have the interface, and this will expect Spark syntax. You put the syntax there, and you query the data set that you put in your website. Okay. So step one, we need to define some properties, right? So again, recall that properties are the relationship and attributes of your ontology, right? So a property is basically just some sort of number for Wikibase, but only makes sense in this situation if you give that a label, right? So the number will be something like P1 to P9, but then you want to give them label to make it meaningful. So instance of, you define something as a part of some broader category, subclass of, some categorization, as transcript, as media file, as message, publication data, etc. Okay, these are all the labels that will define our properties. The kind of situation here is just again to put in some interviews and, for example, that you have collected, right? The data types that you want to define in your ontology are, of course, item, URL, media file, string, point in time, and quantity, right? But again, other can be decided and defined later on. Okay. So first step, you need to create this property. If you want to only have it here, if you want to import the data, it's important that you will respect the order because, of course, Wikidata will not provide you the option to set the number, the identifier, but it's going to be generated sequentially. So you need to follow the order correctly. If you're not, then we have a problem in doing the data import later. We get an error, okay? So you just follow the order that I created here. So you can go to the document now here. So it will be the import guide. I think it's this one here, okay? All right, so these are the properties, and this is the order that you're supposed to follow, okay? So the first one is instance of. So you go here, and then you create your new property. And the only thing that is required is the label, instance of, and then the data type. Here you pick the data type. In this case, of course, instance of will link some item to another item. So the data type, so the end point of your connection or relationship is going to be another item. And you create this here. No, sorry, not geographic type, item. And then you created it. Okay. And then, of course, it's our first property, so it's going to be P1. Okay. So we quickly do for the 9 here. So subclass of is going to be P2. So go here, new property, description sub class of, and then item. Okay. And then has also item, property, label as, and then item here. Okay. Now, we're going to do something different now because now we have transcripts, which of course data type is not another item, but is instead our URL. So a string, which is a URL so that you can click. So here, new property, what is it again? The label exactly as transcript. Okay, and then pick here URL. Yeah, create. As you can see here, you're creating property. It's pretty straightforward. Okay, you can teach anyone to do this in basically 2 seconds. Then as media file P5 as media. Of course, here now the endpoint is going to be a media file. Okay, which you can pick here. Commons media file. There we go. That's different. Okay. Then P6 has message. This time it's going to be a string. Property as message. And here it's going to be string. Okay. Create. Now publication date is going to be point in time. Property. Publication. Point in time. Okay. As sentiment, a quantity, so it can be a number. Your property as sentiment. So let's think about the results of some sentiment analysis here, right? Quantity here. Create. And then finally, mentions is going to be another item. Property. Mention. Sorry, what I said, mention. Yeah, that's mention. And then another item. Okay. All right. We haven't entered any single data item here. We just created the schema and the ontology at the same time, right? Or the code book, because of course you have the number plus some specification of what this property should point to, right? Which is here, data type here, and then you have also the label, right? So for example, our by the way, all these are now pages in my Wikibase, right? So you can do for, and I go to as transcripts. Okay, you can change this. You can add additional labels. That type is URL there. Okay, this is never going to change. Okay, so now we have the property. So what we can do is import some data, right? We have set the properties. So now we import the data, which is going to be embedded into that specific ontology, or better, the ontology is going to be the structured data, the structure layer that I put on my data. Okay, so I go back to the repo on GitHub. Okay, I don't need to download it. I can just do the quick copy and paste. Just make sure to paste everything. So you see here very quickly what this is doing. Okay, go through all this sequentially and just create an item MP. And then we'll create another item speech, okay? And then we'll add some label, right? Here, create all the items. The Q1, we just created the P1, right? The property. And then after that, we'll link this. Well, we'll create another instance and we'll link them, items that we just created through properties to other items and to other data that we want to create, okay? If you scroll down here, for example, this is connected Q1 through P2 with Q3. Okay, we don't use label here. We don't need labels. Okay, here, for example, we're just adding some labels to it. Okay, so just copy everything. All right. Okay. Now I go to the quick statement. Okay. I do the new batch. Yeah, I need to log in again. This is a different website, so you will need to log in again with the same account that you just created, right? So now I need to just log in, of course, because the cookies have remembered me. Okay. So now I go to quick statement. Okay, where is that? Oh, here. Why doesn't it allow me to log in? Oh, hello. Oh, there we go. Now I log in. Okay, you need to log in. A new batch. I copy paste my data here. Okay. So my data is not data actually. This is a script, right? Including the data, and then I import. I click on import. I think. Sorry, here. Okay. So this is basically I just created all the different commands. I have, I don't know, many 114, right? The last step, so you can see here what are these commands are doing. Create the item, for example, there. So then you go on to page 50, and then you have creating other item, but you actually here, so you create the property linking to items, okay? You haven't done anything yet. The last thing you want to do, and then you add statement here, right? The last thing you want to do, you just click on run. Okay, and then you go up here and it start working the way through. Will take a few seconds, and it just like gonna run through all the statements, and now he's creating the data on your website. Okay, if you get an error, green as usually is good, red is not good, so you get an error. Let's see what happens. If you misordered the properties, you will get an error. Because of course you're assuming these properties to be compatible with this data. Okay, the ontology is not interchangeable, right? Has to be compatible with that. And then once you have it, you can actually start going back to your website. You start seeing the data being introduced into that. Okay, all right. So again, this is basically different phases. So we created the 7 items, class items. Set 30 individuals, instance of people, dates, etc. So people, post, whatever, and then the different 77 statements. Okay, so we have some data now that is meaningfully to query, right? So let's go back there. Yeah, you see here we have some error. No idea what is that. 4 errors. So we can double check the errors and see what happened. Okay, let's see if we can find the errors or not. Errors.
You just like Wikipedia.
I made a file. I don't know what is it. Probably because the file is not there. Yeah, they're all on media file. Maybe we did something wrong with the coding. I mean, it doesn't matter. It shouldn't be a big issue. But again, if something goes wrong, then you have an error. You can rerun it. Okay. When you have large data set, you will always get some sort of error. Okay, I think we have enough data in any way to do some meaningful query. And then you can also, of course, create this one by one. Okay, we can try to do it. For example, if we have created the properties, you can create some item. You just click on new item here. And then you just define some item of sorts. Okay, you don't actually need to do anything else. Just the label will do. Well, actually, technically, you don't even need the label. I'm just going to create some item with some number there, okay? Which of course is sequential. So we created 37 items. So this is going to be 38, okay? And then you can add a statement here. So basically we're doing this now manually what we did before programmatically. You can link this through the properties that we already have. So for example, has transcript, has, let's say, sentiment. Of course, this will require a quantifier. So I can enter the quantifier here, 293. Okay, and I save the statement, and that's created. This, of course, is a manual version of doing exactly what we did before computationally and programmatically. Okay, any questions so far? Another thing that might be interesting to do is merge items. Once you can, when you want to merge them together, it's something to consider. Again, that you can do. Okay, final step, doing the query. Okay, so using the SPARQL language to to navigate the graph so that you can pull the answer that you want, right? So now you go to the third different website that is created for you. So you can go here for, actually, let's keep this on, and that was already there. And a few basics here. So if you're familiar with, anybody is familiar with SQL? Yeah, okay. There is something there that you select. Of course, you define what you're going to select, which are going to be. So this is going to create, SPARQL is going to query a graph, but it's going to return a table, right? Because of course, it's the basic format to investigate the data. So the select will define the columns of this table that you want to return, and then of course the different condition here, right? Then you use some prefixes to make your the syntax a bit more manageable, okay? But if the matching. The triple matching that you're going to do will look like this, okay? So this is just a variable that you have defined. MP, you can use whatever. It's identified by the fact that you have a question mark before. And then here you're using the property that you define in the ontology, okay? So WD will be, again, the short prefix for the property, and WD, which of course comes with Wikidata, will be the actual item here, okay? So what this is doing is basically to pull out all the instances of whatever that are linked through the property P1 to the item Q1. Okay, the property P1 is the property instance of, okay, and the item Q1 is MP. So just basically telling the software to give me all the items that I call MP, but I can use a different variable name that are linked to something through that specific property. Okay, so I think I have a few queries here, not in the slides, but they're just here. So if you go here, import data, here. Okay. So for example, this is one will be the first query we try. Okay. You just copy paste this here. Okay, so let's just break it down. Again, this is basically what I defined. Okay, MP will be the item MP. I want to pull the label of that specific item. Of course, I don't want just a number because it's not going to be telling me anything, the identifier. Then the speech will be another item of class speech. Okay, and then I want the label also for that. This service here is just the service that is telling me to pull the item and associated label with it. Okay, which is basically this part here. Again, this is a bit more just copy pasted. Don't worry about that. This is the part that you really have to define. Okay, you have the three statements here that are going to define where your search specifically and how you keep it. Okay, so you want the MPs, and how I define MPs are all the items that are connected by the property P1 instance of to the item MP Q1. Okay, then I also want another filter. I want all the MPs that are connected by the property P3 to something that are now called speech. Okay, I don't define it because, of course, this will only connect something speech. This property specifically only connect in my ontology, only connect MPs or people to their speeches. Okay, so I don't need to specify here a quantity. This can be replaced by any word I want. And then here, again, I put the same thing here, where speech is some entity linked to property instance of, actually, if you hover it, you see also what they are labeled, to Q2, the Q2, which is the speech entity. Okay, item. All right, you run it, and then you get your table below. Oh, great. So there was an error, actually. Perfect. And it's not pulling out anything. Great. This is the law of demos. You do it and they don't work. Let's simplify this. Okay. Okay. Let me go back to the data and see whether I actually put in some data or not. Did anybody try to run this and with a different result?
I'm also getting an error, but slightly different.
Different errors.
but I also had a lot of errors on the import, so
Okay.
probably why.
All right. Yeah, I think the problem will be likely with the query with the data import. Okay. Let me try something else. Let's see what happens here. Okay, this should probably work because this is basically pulling out all the items that I have there without. Okay. So this is a simple. So there were probably some issue with the numbering. Okay, this is basically a more general version. It's just like, yeah, I know what is happening. Is that it's probably the short. It's probably the the prefix. Okay, so let's stay with without that. That can be solved in a few steps. I think it's not reading correctly the prefix. Anyway, so this is basically pulling out all the items with the corresponding label. Okay, so you see here the item and you see here the corresponding item. So this is working because it's not using the it should also work. Okay, let's write something, another label. Let's write this one here. Not working?
Tried to make it as simple as possible and it happened.
Okay. Let's see what is this working out. Yeah. Okay. We need to take this out. Maybe it's the labeling part that is not working.
Yeah.
Anyway, I think you need to trust me on that. So I don't know why it's not working there. Let me try this. Just also this one here. I mean, at least we have one working. Yeah. Let's simplify to the max. This one here.
Is there select everything like in usual?
Is the one that we just did before. So let's try just to do MPN and label where this is. Let's try just do this. I think the problem might be the prefix specifically that it's not returning stuff. Let's try to do without this. Yeah. Anyway, no luck. I think the prefixes we were not able to set the prefix correctly. So yeah, we will need to trust me on that. Anyway, this is a different. Again, this is the tweaking part where we need to specify where we are pointing here, which I should have tested better before. But this is basically a different kind of queries that you can point to. Okay, just a very simple example that will allow you to pull out the data that you have entered by specifying the different think about it as a set of filters. Okay, like I want this, but I want a post that is an item that is basically instance of being a post, but I also want a theme that is a post that specific theme here. Okay, so here you're defining with this statement instances of posts. Okay, here you're defining instances of a theme, and here you're defining the filter saying I want posts that have a specific theme. Okay, which probably we haven't finished because of the error for some sort entering into that. Okay. Okay, so again, that part didn't work. So, okay, I'm sorry about that. But yeah, you can definitely probably try to, instead of using the automatic import, to enter the data manually and see where you can still do some querying based on that. The good thing about this, again, when things work, is that this really allows you to scale up quite significantly. Okay, because you have this data interface here that allow you to navigate the all your. So, for example, if you go here to recent changes, you will see you can navigate every single item manually, and then you can go from one to the other by just clicking on it. Okay. But then again, with both the API and the quick statement service, when it works, you can really scale up and then enter data on a much larger scale, with the idea that then you can intersect the human component of your team and allow them to add an additional layer of information, right, generated by somebody opinion, for example. So this is exactly what we did for in our project. So we had the human coder that were going through the website manually, like this, reading the speech, and then, so let's say this speech here, okay, adding a label or linking this to some specific theme, okay. So for example, as well, we didn't specify that, but let's say that you have a theme property and then something, okay. Doing this manually, which is quite convenient, because let's think that you have a specific file transcript that is not there, but think about linking this to a specific page there. You can click on this, you read the transcript, okay, which is an unstructured page. Then you go back to this and you add the structure, so the linking this item specifically to some sort of theme. And then, of course, you can use some computational method where you pull out all the humanly coded transcripts, right? You do some training using the human layer, and then you put it back in. And then actually what we did is that we sent it back to some person to double check the quality. And then we went back into the computational classifier so that the classifier could improve based on the input provided by the feedback provided by the person that was rereading and see whether the actual classification was accurate or not. Okay. The other interesting thing, of course, we haven't done because we started this way before LLMs became popular, but is exactly this kind of integration with computational means, so that you have your data that you can navigate through easy enough interface. Okay, and then you have some LLM classifier, some script that is pulling the data out, is doing some LLM classification, and then pulling the data to data back in. And then, of course, this can enrich, and I add additional layers to your project. Okay, so just briefly, this is what we did without the LLM parts because they were not available yet. So our project originally was about looking at social media use in Melanesia. We wanted to see whether we could detect any foreign interference, so people from other countries to interfere with the social media conversation. So we had a large, manually collected corpus of social media posts. We had them navigating the social media posts, copy pasting into Wikibase. And then so of course, that was the original injection of the data. So then we started adding structure to this data set. So we were linking authors. So for example, social media accounts, we'd recognize that the same person, right? With the puppet master kind of situation where you have the same person maneuvering different social media accounts. So you can add that information into the social media, into the Wikibase, but also you can connect all the text that you have collected different themes, right? And once you have this, of course, you can start doing queries, quite sophisticated queries, to try to investigate and identify connection, okay? Because, of course, you can have very complex kind of paths that you kind of investigated from specific items, specific actors in our case, to specific themes. Recurrence, you can use dates to filter and to see whether there are any specific patterns. And then, of course, you can integrate that with other tools once the data is out of, in a tabular form, is out of the knowledge base. Okay. Other cool things that are included in the package are, of course, version control. So, like we did some mistake here with the import, and you can go back and see exactly what was introduced at what point, and you can reverse, right? So if you don't like something, you can just go back to it. You also have, as being a wiki page, you have the total page, okay? So you can basically, review the history here, but also have a discussion about the item. Okay, so think about this all in the same kind of repository. So for example, here, let's say that this is some sort of items. We want to have some sort of discussion, all right? And among the different members of the groups, and you can have this in a very compact form in the same kind of website, okay? And within this, of course, you can also use some sort of tagging, right? Wikipedia use tagging all the time. If you go to any page, okay, and you go to the discussion of the page, and this is everything that you see here can be implemented, of course, in your Wikibase. Okay, so there are different tags within. So who is talking, who is responding, but also whether something is tagged as something specifically that you need to go back to, et cetera, et cetera. So there is a complex tagging system you can use that allow you, of course, your team to collaborate together. And then you can export everything as any of this format. Okay, so once you're done, you can export, you dump your entire knowledge base. You can use different format, which of course are very open, okay, for others to see it and read through. And this really speaks to the, I don't know whether you mentioned this, but that really speaks to the open science kind of approach, right? So this is not just a database. This is also a repository on how the data and the project evolve together. Because with the version control, you can go back to the different discussions. So you've been coding something blue or red, you can go back to the told page and see exactly why you justify that part of that specifically intervention or not, okay? And, well, assuming that you protect the privacy of your participants, you can, of course, export everything. So you can also give access to other researchers to the entire told page so that they can go back to that specific decision and see whether they agree with that or not, right? Okay, so just concluding. So much more than a database in our approach is we define it and we use it as an interdisciplinary workspace with a lot of flexibility. Okay, so this is of course Wikipedia, the software behind the Wikipedias with Wikibase allow you a lot of different kind of provide you with a lot of features. You don't need to use them all, but of course, potentially you can. That also gives a lot of flexibility. So depending also the kind of skills that you have within your team, you can define a different, a specific workload that really is tailor-made around your specific, your needs. And it also provides an essential kind of bridge between the qualitative and the quantitative, right? Which is the base, especially in the social sciences, coming from the social sciences. This bridge, this gap, which is sometimes a wall, is really one of the most significant barriers to real interdisciplinary research, okay? And the problem is really the fact that we don't have enough tools that allow us to create this space where everybody will feel comfortable. I think that Wikibase, more than other dedicated software, so for example, NVivo is something that can replace some of the function of Wikibase, are much more difficult to access, right? Try to open NVivo and tell somebody to do something, and it will probably take some time to learn how to do it. Wikipedia is much more accessible to navigate and to investigate. Okay. Yeah, I think that's it. Any question?
Any questions? I might start.
Yeah.
I think maybe the first one, we've actually talked about interdisciplinary collaboration, and we had a panel on it.
Yeah.
We didn't go as much into theory of interdisciplinarity, so it was great to have you provide a definition of what it is and what it is not, and how it differs from cross-disciplinarity and multidisciplinarity. So that was really useful for me personally, hopefully for others as well. I mean, reflecting on your experience with it, how do you convince people to actually be on board with this? Like, we also talked about kind of different tools that people use and managing your time as a PhD student, and we've had some discussions around some people have developed systems that work for them, but when it comes to collaboration, they, for example, cannot work in a shared Google Doc because they're a computer scientist and they're very used to LaTeX, right? Mm-hmm. So how do you navigate that when you're trying to get people on board with Wikibase? Yeah.
I mean, if they really don't want to make the effort to learn how to use a Google Doc, I think you should not even try. But if they have some sort, I mean, because that's I think it's an important point to start with. So there are colleagues that don't see the point of doing it because they have a very strong, it can be legitimate, by the way, very strong theoretical, epistemological position that is not compatible with that kind of research, right? So there is no point. I mean, you can have a theoretical epistemological discussion, ontological discussion, methodological discussion with them, but there is no point in bringing them on the same project if they don't agree on that kind of preconditional facts. Okay, this research can be conducted using mixed methods, for example, or using a number of different methodological approaches. So if that is not the case, so if there is some, as people would assume that they would agree that there are potentiality, there are opportunities to explore going outside of their discipline, then you have the opportunity. Okay, these are the kind of people that you can bring on board. In general, again, if they say, "Oh no, I'm not going to do this. I'm not going to use this," then probably that's not the kind of battle you don't want to. You don't pick your battle. Right? This is the kind of battle you don't want to fight. But then, if there is this, they see the opportunity. They understand that the research problem can only solve with an interdisciplinary approach. Then you can start working. And the real word there is defining the work process and the workplace, right? And so you want to find, Wikibase is one, but in any case, doesn't need to be that one. But you need to find the tool that allow them to feel comfortable enough to participate and not be excluded, right? Because you can have a very much unbalanced interdisciplinary project when one voice is much stronger and is dictating the vocabulary to use, for example, computer scientists or psychologists. And then, of course, the person from another discipline will not feel that is in the position to contribute because not understanding what's happening. Okay? So you really need to create an equalized kind of situation where everybody can participate because everybody can understand what is happening, what everybody else is talking about. And again, Wikibase does not need to be this, but if what you will need to build is this kind of common place where everybody can understand everybody else. Only if this happens, of course, everybody can contribute in a meaningful way. Yeah, but not everybody is open to do this, and this is kind of the first thing I think we want to learn.
Any other questions? Perhaps looking back at some sessions we've had around CPs and other things. Anyone see?
There are games.
There is an MCP. We had a session on MCPs and connecting the LLMs to external sources and having them execute.
Yeah. Oh yeah. This is the LLM part I was talking about. So exactly the kind of interface the MCP is of course machine entering into your knowledge base, and this of course the opportunities. Potentially here is sky's the limit there, right? Because of course as soon as you have both, well, LLMs can also read into the unstructured part, so you can leverage both. But then you can also have a theory system that instead are leveraging on the graph structure to pull out the data.
Probably saving a lot of context as
well.
Saving a lot of money.
Because that's going to be the biggest challenge when you integrate these tools in your research is optimizing the tool, because you cannot just. Eventually, maybe in the future, we'll just be able to drop everything in and make these tools will make sense of it. But we're not there yet, and maybe we don't want to be there because you still want to be in control. So you will need to create the layers that this goes through, and of course, this kind of queries is one of potential of these layers. You define the entities, you define the relationship, and then you give them this kind of vocabulary to pull out the information that they want to do, that you want to get into.
It will be probably useful for a single researcher as well. You have to keep your project structured.
Yeah.
And you just...
I use it for collecting research papers. Yeah, I use it for pulling not the actual paper, but just information from Crossref, and then I pull it there so I can search it. As I don't want to rely on Google Scholar, for example. Yeah, any kind of this kind of project where you create a knowledge base. It's pretty useful. Yeah.
So it's like you're Zotero, but you're also doing a form of systematic literature.
It's integrated with Zotero because it does not store the PDF.
Yeah.
So I have a script that monitors Crossref for the publication I'm interested in. And when something is new is published, I will pull the information from Crossref. Is this open source? is this project here. Okay, so it basically brings together, not at the same level, but different publisher, and they will publish so they will provide the data to Crossref with that, which is then providing the data, serving the data through APIs, and then you can query the data for author, publication date, etc. And some publisher will also provide the abstract, others will not, but you still have the title and the publication, so you can link them together then.
Do you have that script on your GitHub open access?
No, but I'm happy to share it. Yeah.
I'd love to have a look. That sounds great. Any other questions? I'll try for the last one more. Is it hard to persuade ethics committees when you write up your ethics application and say we're going to use Wikibase as a collaboration tool? Do you ever have problems with that? Like any ethics committees flagging that?
Well, that's a good question. I don't think we specified that. So, but any ethics committee is different. But in our case, they're not really interested in the tool that we're using. It's mostly where the data is.
Mm.
So if we're saying that the data is going to be located on the servers of the university, they're going to be happy with that. So I don't think we explicitly mentioned Wikibase at any point. Okay, I think the ethics is just about where is the data, who has access to it, and then of course the ethics part for you will be to guarantee that you don't give somebody access to the data, so you don't publish it for everybody that is your research assistant not using password as a password, that kind of thing. Yeah.
So then obviously your project would be, you would host your own server rather than relying on the cloud solution.
So yeah, you can explore that depending on the requirements of your ethics committee. Yeah, and I think in any case is if your project is going to run for a few years, you can put together some hours, set it up on some server provided by the university. So for example, you can run it using Nectar for free. So then the only thing you might want to pay with your research fund is the domain name. So you don't want just to have a number. You want to have some name that you can integrate the name into every single entity that you want to publish within your project. And then, yes, you add, you can use a VPN or some sort of way to make sure that the different websites, so the wiki, the query services, the statements are accessible only through a password. So that can be done. Yeah.
Is there a way to vary visibility by object?
That's a good question. No. So, I mean, it's open source, so you could do it. But then, of course, this is the limitation. The project that is paying for this is Wikipedia, so everything is public. So there is no differential kind of privacy there. Yeah, this is exactly the same point we had. So, for example, can we publish something and not something else? At this stage with this software is no. So it's either you publish everything or not. So the only thing that you could do is you have different versions, right? So you dump the entire data and then you filter information out that you don't want to have. So you maintain some structure, selectively taking out some of the items, okay? But that will be a great addition. And of course, since the project is open source, I think that in some sense, somebody might eventually develop it. But yes, no, the problem is that the Wikimedia Foundation is just about everything public, so they don't care to invest any resource there. No, unfortunately, no. But yeah, that would be a very good addition to this. Yeah. All right. Awesome. Cool. Thank you for your time.
Great way to end our workshop sessions ever. Till next year. Till next year.
I think there were many things that kind of, I think, echoed some of the other sessions that we had.
Yeah.
Especially collaborative work and then the theory and also pre-processing. And then,
Yeah.
And MCPs.
MCPs.
Yeah, I mean, every research project is different, so you need some sort of flexibility and capacity to go back and correct some of the errors and just
Absolutely. Thank you, and I'd really like to see if you are open to sharing that
Yeah, sure.
literature.
Project work.
That's
Yeah.
such a